Yes, because they are summarized from the sample that are independent from each other. Alright. So we use these two, the difference of these two. Same thing, you have to know which one minus which one. Alright, to estimate the difference of means. Right now it's difference of means. Before is the mean of difference. These two are not the same. Alright, now it's different of mean. Right? So this thing is equal to difference of two means. Alright, mu1 minus mu2. Alright, at the end, the hypothesis, right? Hypothesis will actually be about the difference of two means. It will be about mu1 minus mu2. Mu1 minus mu2, right? Same old thing, we have equal sign on S0 compared to different that you care. And on this side, you have less than sign, greater than sign, and not equal sign compared to difference. Alright? If these are 0 is 0, your question is about is these two are the same, or which one is greater or smaller. If you change this one to be something else like 2, it's more like you asking if mu1 different than mu2 by 2 units, something like that. Alright? At the end, it's about bar. At the end, you want x bar and y bar go to normal. Alright? If this one go to normal, normal minus normal become normal. Alright? So the condition remain the same, but now you have two samples. You apply the condition on both samples. Alright? So there are two conditions. Right? The first one, conditions. The first one would be two independent random samples. Random samples with S. Because you have two samples. So each one are random. And once the first sample is independent from the other one. Meaning that when you have to check, you have to tell me whether they are random, whether they are independent. You have to explain why independent also. Point here, right? Okay. Right? Independent, for example, there is no overlapping from the two samples, something like that. Or maybe they are not matching up in any way, those kind of things. Alright? Two is talking about sample are from normal or n is large. So in this case, you would say both samples are from normal box or n1 and n2 are at least 30. Just like that. Alright, to make it simple, just both are normal. We check that histogram will shape approximately. QQ plot, they both look straight line. Same old thing, but we check 2 times from sample 1 and sample 2. But if sample size from both of them are large compared to 30, okay, fine. Alright? To be accurate, if one is small but have bell shape and the other one not normal but large can also okay. But to make it simple, just write it that way. Okay? Alright? If you want to make it easy to remember, now you have 2 samples. You apply condition twice on the first sample and second sample. And independent just comes with when you choose this test because both samples are independent. Alright? At the end, what you have is that you're going to have confidence interval. You're going to have the test for that. Alright, just basic that. So right now, this one is actually called two independent samples, t-test for mu1 minus mu2. Sometimes they call it 2 sample t-test for short, something like that. Right? So today we have learned 2 new tests at S for mean of difference. And now we talk about independent sample t-test. Right, for the difference of 2 mean. Alright? Right? Now, if we go to the sheet look more boring. See, let's talk about this page on page 7. Alright? On page 7, you see, it's talking about independent samples. Alright? Now, your main goal is to talk about the difference of two means. Alright? We estimate by the x bar from group 1 and x bar from group 2. So the one I wrote is x bar and y bar testing. Alright? And then assumption would be just like independent random samples. Both samples are from normal and is large for both of them. Alright? If this condition apply, this one go to normal, this one go to normal, normal minus normal become normal. That's just technical thing. Don't worry too much. Right? And then at the end, you're going to have a version of confidence interval and the test. But now the one that you're going to be focused on is actually test 2. The z-test we never touch because in the software, we never know the real SD or variance. Take a look at this one, right? Now, turn out that the complication becomes that now for t-test, there are 2 sub-cases. The first case is when variants are the same. And the second case will be when variants are not the same. Right now, just want to make sure to be aware that when 2 sample t-tests, there are 2 sub-cases when we assume variants are the same and the variants are not the same. But the main goal are the same, is to estimate the difference of two means. Alright? Usually, we prefer if we can assume variants are the same because it will give more power to test or results. If we cannot assume, then we can use another one. Right? The formula, don't worry, we're going to take a look at the output. Right now, be aware that there are the cases that variants are the same or variants are not the same. Alright? Now, we're going to jump to the first sheet that we talked about, the department A and department B. This sheet, right, we talk about two set of employees from department A and department B. Alright, you have 40 from A and 60 from B. Alright, maybe if we flip to here, right? Flip to this page. See, we have one set of department A and one set from department B. Are these two sample independent samples? Yes. How would you explain that? Yep, because they're from different departments, that's it. Okay, just that, right? Because two samples are from different departments. Just try to say that they're not matched, they're not related. And then, since they're from different departments, so they are independent. That's it. Okay? Right? For example, if you have a student in this class, they break into 2 groups, guys group and girl groups. Are they independent? Yes.
Depends what you're measuring.
The data from these 2 samples would be independent because they are from different gender. Right? Okay? That's how we explain independent or not. Alright, and now jump to output for 2 sample t-tests is basically, before I jump to that, right? Before I jump to that, remember that 2 sample t-tests, there are 2 subversions. One is for variants are the same and variants are not the same, right? So sometimes in the question I may ask, should we assume variants are the same, alright? So there are 3 approaches on how you to tell if variants are the same. The first one is to look at this graph here. This output 1 by 1. This one. Right? This is SA. This is SB. Right? If variants are the same, both is supposed to be comparable. I would say tip here. Comparable. Alright? So based on these two, are they about the same? Don't be too picky. If you picky, everything different in real samples. Alright? If it's not so much different, then you say about the same. I just say this one is about the same. To me, if it's not different by 2 times, 3 times, it's still comparable. Alright? So I would say
Comparables SA SB lead to sigma square A equal to sigma square.
Right. So my point, if you want to say, we can assume equal variance, you want to say that S are comparable, are all the same, not so much different. If you want to say that we cannot assume equal variance, we have to say that they are not comparable. One is a lot larger than the other one. Okay? Which sometimes can be subjective, which is fun. Okay? Alright? You see simple logic using the point estimation to compare. Alright? Now, second approach is Swiss graph. Side by side box plot, right? If variance are the same, they're supposed to have about the same spread level. So what you do, you compare range and IQR. If IQR are both and range from both of them are comparable, then you imply that you can assume equal variance, which sometimes can be subjective. I mean it. Alright? Because like this one, just like the same logic apply. If it's not a big difference, like 3 times, 5 times, 5 times, this still be comparable. But it's kind of like it's kind of go against your logic. But you have been using this many times, sometimes like at the end there will be a test for that. From my experience, if it's not a big difference, then don't make a fuss on it. Alright? Like in this one, right? Same logic, right? So comparables, IQR and range, right, lead to equal variance. Alright? This one is kind of great, right? So that's second approach. Yeah? Last approach, if we jump into here, right? Output 4. Only focus on this box. Only focus on this box only. Alright? You see the name. Levy test for equality of variance. Alright? So this box is for testing if the variance are equal. Alright? Inside has the sig, right? Sig implies p-values. Right? Before you use p-value, same old logic, you need to know what is S0, what is HA. Alright? So now this one is talking about testing if variance are the same. Equal, put on S0. Not equal, put on HA. So now this one is for S0, put sign, right? So right now, H0 would be, if you pick H0 mean you assume equal variance. If you choose HA means not equal variance. Alright? To make it easy, because this one is not the main thing, right? We just choose should we assume equal variance or not. So if p-value is large, let's say larger than 5%, equal variance. Right? If it's small, smaller or equal to 5%, variance are not the same. Yeah? This one is the best one because it's done, no subjective. But it's always help if you have the number and picture to convince you that everything go the same direction. If it's not go the same direction, maybe you make it wrong decision, or maybe it's gray. When the result is gray, sometimes three different approaches might lead to different answers. Yeah. You see right now that we approach to compare the variance are the same or not by point estimation compare SD. by compare IQR and range from side by side box plot. Comparable S and comparable IQR and range imply about the same variance. Alright, or you can use the B case of this output. Alright, P value, if you see the name equal variance, put on equal by 0, not equal here. Same logic, if this one is not small, not smaller than 5%, then equal variance. Large, equal variance. Okay. That's about the variance, right? Now let's talk about the mean, the difference of mean. Alright. Now let's talk about this output in more detail, right? You see output 4, the name here is a independent sample test, right? So this one is basically for two independent samples t-test for mu minus mu. So now let's before I write down the subscript then, right? Now you have to talk about the difference of two means, right? Now if you take a look, right, don't write the subscript, see? Right, let's take a look at output, right? Now we need to know which one subtract by which one. What you see from the output here, it doesn't say. I don't know why. So based on output itself, it's hard to tell. But if you are the people who make the output, you need to know what to do. Alright? If it's an exam, I will put the name in here. Right now it's A minus B. Right? Keep in mind that meaning that when you make your own output, you need to know what they are. Or maybe when you make report, you have to make it very clear which one subtract by which one. Right now it's A minus B. Alright, if an exam I don't give you ask me. Okay? Alright, so it's A minus B. Alright? Now I want to show you that the result itself, the two sample t-tests, there are two versions, equal variant version and not equal variant version. You see here. This one is a equal variant assumed. This one says equal variance not assumed. What does it mean is that if you choose the result on the first row, is when you assume equal variance. If you don't assume equal variance, you use the result on second row. Alright. At the end, you pick only one row. How do you pick that? By compare S, by compare box plot, or by use the result on this column. Alright? Okay. So in this one, we compare this. So now IQR and range are comparable. It's not a big difference. Also on this one is pretty large. We assume that the variance are the same. So we're gonna stay with the result on the first row. Yeah. Now let's say we assume the first row, right? Choose the first row. Now same whole thing happened. You see, let's take a look at the confidence interval first. Now this one is a confidence interval, right? At the end, right now, let's pick only the first one. You don't use two, only one of them is enough. And you don't compare because they are the same kind of interval, but different formula, that's all. Alright? So this one, right, when you use the confidence interval, ask yourself, this interval is for estimating what? Right now, your main goal is to estimate the mu of A minus mu of B. Alright? So let's focus on the first one. Right? It's for estimate mu A minus mu B. Same thing happened. How to use the interval? Let me ask you based on this one. Can I say A perform better than B? A perform better than B means the score is higher. If the score is higher, A minus B have to be positive. Can we claim that difference is positive? No, because the interval includes 0. We are about the same. See? That's that. right? How about if I take out negative sign here? Now they both become positive. Huh? Based on this one, can we say that A perform better than B? Yes, because the difference are all positive. Right? Now we compare to 0. 0 are the same, mean the same. Right? If positive, the one before is larger. Right? If it's negative, the one before is smaller. See? Right? Now we use interval, same old thing. Are you confident your answer? Based on 95% confident interval. Okay? Put that off. Right? But keep in mind, when you do answer your exam, I need to know which one you pick. Alright? Because sometimes you pick different one, the answer could change. Like in this one, if you follow the step, you assume equal variant, you choose this one. But if you don't assume equal variant, you choose this one. Right? So that's about confident interval. Next one, right, is this part here. This part here. This p-values. Right? Then one thing, when you use p-value at the end, you pick only one of them. Equal variance assume use this one. Not equal variance assume use this one. Alright? So let's say now we have p-values. Before use p-value, remind yourself what is S0 and what is HA. This one is said to tail. By default, the test, right? By default, the test is only for mu A minus B compared to 0. Equal sign and not equal sign. Alright? 0.087, right? Let's say alpha is 10%. Let's say alpha is 10%. This is large or small? Large or small? Compare 10%. This one is small. Small, you choose down here. So A and B perform differently, but cannot tell which one is better. To want to know that, you have to go back to look at the sample means, which one is larger. Alright? Or you can try to extract the p-value for one-sided test, that's okay also. Alright? Alright? But if alpha is 5%, this one is large. Large, you choose this one. So they are no different. This one implies that the sample to sample is somewhat gray. Because when you change alpha a little bit, the answer could flip. You know? That can help, but if the sample is gray, the choice of the two is very crucial. Right? This one is the best one because this one is customized to detect different of 2 meters. The one before is only for 1 meter and a half. Right? Okay. You see same old thing, right? Confidence interval. Alright, we have the p-value for testing. Alright, for the output is only for equal and not equal sign. One thing you have to be very careful is that in the output itself there are 3 p-values, which I don't know why SPSS do like this. This one is the not important one. This one is important one, but this one is help you to choose which version you're going to use. Right? That's why I put here to be S0 and HA as a star. It's a sub-test. It's not a main test. Alright? So remember, you have to choose first, should you assume equal variance or not. Assume equal variance, only use the p-value on the first row or on the interval on the first row. If you not assume equal variance, you use the result on the second row. Alright? And don't confuse this p-value with this p-value. Those are the very common mistakes that most people do. Yeah, I don't know why they put that in up front. Okay, all right. Now let's go over the question one by one.
Do you understand?
I'll start on question F.
right? Because what is ACE, we have done that long time ago.
Opportunity cost, right?
Now let's see, right? F on output 5, should we assume that the variance of performance score for both department A and department B are equal? Output 5 is basically this one, right? Output 5. The question asks, based on output 5, can we assume equal variance? What kind of thing you have to talk about? Comparable IQR range or not? Right? And we have to decide, should you assume equal variance or not? If I were you, I would look at this result first. Alright? If this one lead to equal variance, I want everything to go to equal variance. So that is easy to write. Alright, but it's okay to say differently also. Alright, this one I would say comparable because it's not a big difference. But if you think it's different, it's fine to say different. Alright, so in this one I would write something like, well, based on output 5, right? IQR and range from both box plot are comparable. So we can we should assume that the variance are equal. Okay. Let's talk about comparable IQR and range. Usually I talk about both IQR and range because sometimes even though range are the same, maybe IQR are different. Right? If you're not sure, it's okay. It's okay to be selective, but just go along with what you see. Right? Second one, the G. That's the answer in F. Right now, F we say we can assume equal variance. Right? Does this answer consistent with the result in output 1 and output 4? Right? So now it says, is your result from previous questions consistent with output 1 and output 4? Alright? We go back to output 1, right? Remember that now we're talking about equal variance or not, right? Output 1 is this one. To be able to compare variance are the same or not, you have to talk about SA and SB. Alright? Are these two comparable? Yeah, comparable, then consistent. Right? Because if they're comparable, variance are all the same. Right? And then that's output 1, right? We talk about S1 and SA and SB. Alright? Output 4 is basically this one. This table. You see, there are many numbers in here. Alright? If you don't practice, you don't get what's going on. It will be bad. Alright? Now, equal variance talk about this part here. Remember, you talk about this p-value. You know p-value, remind yourself, before you use, remind yourself what is S0 and HA. This one is talking about equal variance, equal put on S0. Not equal with put on HA. Or if you want to take a note, just say this one larger than 5% equal variance. That's rule. Very simple, right? So this one, about 20%, larger than 5%. So S0 equal variance. Result consistent. You see, step is clear. But now there are too many steps, too many approaches, right? So how we write, right? Output 1, right? SA equal to 1/5 3.73, right? And then SB is equal to 4.99, right? I say this is equal to SB, and these two are comparable. Alright, so we can, this one is equal to this one. Something like that. So you talk about that these two are the same, so that's why we can assume that they are equal. Alright, from output 4, right? From the test, p-value from the test, right? Or you can write down S0 and HA also if you want. Right? So this one is this. This one is this. Right? This one is equal to 0.208, which is not smaller than 0.05. So reject not reject S0. So the same. Consistent. With F. I don't think like when you do exam from the pre-course, right? If you know what's going on, it'll be okay, right? If you know what's going on, you will try to write and erase, write and erase, or maybe just blank there. You know. Any question on this one? Okay, man. So you see that if the results are very clear that the variants are the same, all three approaches supposed to be on the same direction. Alright. If we have the different directions, sometimes different approaches lead to different answers, which is fine. But if you ask me which one is the best to use, I would say use the Lowy test because it's always lead to just one answer. Okay. Part H, right? Based on output 4. What is the p-value for testing? If the employee in A performs better than employee B or not? What is the conclusion at significant level of 1%? Right? Right now you see it's not like a complete, now it's asking for p-value. You have to give me the p-value. Alright? And then the same old thing. First, when you see this thing, we have to extract the research question. The research question is A better than B? Alright? And from research question, you translate to stat question. Right now, you only talk about the mean. Alright? A perform better than mean. B is mean. Mu A minus is greater than mu B. That's the research question. Right? Okay? And that's the same as mu A minus mu B is greater than 0. Right? Right? So in order to get p-value, remember when we learned how to do hypothesis testing, we break them into 4 steps. 4 steps still work. First step is to set up S0 and HA. Alright? So basically, your question here can break to, when you say yes, right? Mu A minus mu B is greater than 0. When you say no, it's a mu A minus mu B is less than or equal to 0. Alright, same old rules happen, right? We have equal sign, put on S0. The other one, just put on HA. So step 1 in here would be, step 1, S0, mu A minus mu B less than or equal to 0. HA would be mu A minus mu B less greater than 0. Right? Yeah. Step 2. The question itself don't ask to check for condition. I'm going to skip that part for condition. If the question don't ask, you don't need to do. You do it, it's fine, but no more point there. Because if I keep asking condition every time, it's going to be boring. Alright, but sometimes I ask. Alright, so step 2. Step 2 is what? Step 2 is to check condition and summarize to test statistics. Right? Let's get test statistics. This one is for independent sample. Talk about difference of two mean. It's called two sample t-test. So summarize to t. Alright, if it's t-test, summarize t. C-test, summarize to c. Later on, we have chi-square. Later on, we have f-test, those kind of things. So t, how do we get that? We go back to output. Go back to output. Before, do we assume equivariance? Yes. Meaning that we're going to use the result on the first row. But if you don't assume equivariance, you have to pick the value on the second row. Alright, t-test, this is your t. Right, 1.7131. But you pick the other one, this is one. They are not the same. I have to write down. Because if you let me guess, I will guess wrong. Alright, so this one, t is 1.731. T is 1.731. Alright, step 3. Step 1, set hypothesis. Check condition, summarize to test statistic, in this case t. Step 3 is what? To get p values and compare to alpha and decide reject, not reject. Alright, isn't t-test? T-test look like z. It look like normal. It looks something like this. Alright, t-test, you put t is right on this side 1.731. Remember that in the middle for t is 0. Positive on right hand side. Right? That's how we draw this line, right? If it's negative, it's on this side. Alright? And now, area on right hand side or left hand side. Look at this side on HA. Greater than sign, area on right hand side. Greater than. Less than sign from this point to left hand side. Alright? So you talk about this area here, right? Okay. So now, how do we get this area? Alright? You go back to your p-value on this one. This one is for two-sided. Smaller one, half of this. Larger one subtract by half of this. From the picture, smaller one or larger one? Smaller one. Alright? So meaning that the p-values is equal to 0.087 divided by 2. Are we okay why is divided by 2? If it's this area, it's half, the smaller one, half of from the output. If it's larger one, it's 1 minus half of that. Alright, that's how we use it. Alright, okay. So in this one, you're going to end up with 0.0435. Alright, alpha is equal to 1%. Right, compared to alpha, this is not less than or equal to 1%, which is alpha, so not reject S0. That's step 3. So make sure you know how to do this. Right? That's why on the pre-course I go on this slope so that you understand this picture. Because when people mess up, sometimes people say when you do one side you get divided by 2. No, it's not always divided by 2 because sometimes it's divided by 2, sometimes it's not. How do you know that? The easy way is just look at the picture. Smaller one divided by 2, not smaller one subtract of that divided by 2. Okay? Alright? See, step 3, end up compared to this, not reject. We're not done yet. Step 4 is to go back to answer the main question. The main question saying that can we conclude that A better than B? Just go back to answer this one. Can we conclude or cannot conclude? This one is a not reject. Not reject. Choose this one. This one, right? Does this one imply A is better? No. Right? This is actually answer no. Right? So at the end, just say step 4. Right? We cannot conclude that department A perform better than the employees in department B at significant level of 1%. Also keep in mind that in the conclusion you have to specify significant level. This one is very crucial because if you change to 5%, you will reject. Answer will change. Right? The same old thing. Every test can always break to this 4 step. See? Right? The question itself only asks for p-values, but p-value requires the first step. See? And also, you need to know t also. Alright? And then it also asks for conclusion first step. So to me, for every test, think of this as a condition in Boolean. Any question? ถามไหมครับ
This is for the event, right? 400 baht. 800 for you, no? Oh? 800 for you. 800? Oh my god. You discovered this one, right?
Yeah,
How?
it was on there. It was on here.
Oh, really?
Yeah,
Let me ask you, if I change to
So
perform
I-
verse or
instinctively
verse not,
shared.
when you perform verse, the question you change, this one will be
Instinctively.
less than. Right? And this one
Without
will be
thinking.
greater than or equal.
It's like
Right.
an older friend.
And this thing will be carried on this side. It will be 1 minus this. Still large,
JH.
right? Large, so not reject. So you say cannot conclude that it's worse than B. Something like that. Yeah, I'm saying that. Let me write that in red color, right? So if I change to this one to worse,
Why you start?
worse, right?
Yeah.
So this thing becomes less than. Alright? So this thing becomes less than, this one becomes greater than or equal. Alright? So this thing becomes greater than or equal, this one becomes less than. Alright? T remain the same. Alright? P value become red zone here. Right? The P value will be 1 minus 0.4435. We still not reject. And the conclusion, we just change this from here to worse. Same logic apply. Right? If you can do on both three ways, right?
Same
The
logic.
equal not equal sign, you can use the output right away. Alright? But if you want to do one-sided, you have to modify it somehow to get this kind of picture. Okay,
Same old logic. Same old thing.
Question I.
Illogical style.
Based on output 6, should we assume that performance score from both department A and B are normally distributed? Right? From output 6, right? Output 6 is this one. Right? Based on output 6, can we say that both samples from A and B are from normal distribution? Yes or no? When you talk about bell shape or not, I think this one they both are look skewed to the right, skewed to the left, so they don't look like normal, right? So you say, let's see, these two they don't look normal, they look skewed to the right, to the left, right? So from output to output 6, both histogram are not approximately bell shape. So they are not normally distributed. Alright. In terms of condition, I think both samples are large, both 30 and 40, so in terms of condition are fine. But if you talk about normal, because they look less skewed, right? So this one is less skewed. Right? So that's why they're not normal.นั่นเป็นของทำงานใช่ไหมเข้าใจใช่ไหมครับที่พูดอย่างเงี้ยคนเรามาสอนเองแล้วคนทำงานไปด้วยนะครับไม่ต้องมาเรียนก็ได้ครับโอเคเข้าใจนะครับที่ครั้งนี้เราไม่ว่าอะไรใช้หลอกนี่ไม่โอเคนะครับไม่มีมารยาทนะครับpart J does the answer in I consistent with output 7? In I is actually that's the answer in I, previous one, right? Output 7 is this one. Before we talk about normal or not, right? And the question asks, if you use these two outputs, does the answer still consistent with previous have, right? Before we look at histogram, they don't look bell shape, they're not normal. But if you take a look at this one, it's up to you, it's subjective, right? But this one, you might say, oh, they're not so bad. So this one, it looks straight line. It could be normal conflict with before, right? But this one not. This one is totally not. This one doesn't look approximately straight line. So this one is consistent with that. So you talk about straight line or not. Alright? I go back to write the answer. So I say from output 7. Q plot for A, right, is approximately straight line. Right? Not normal puff, right? Inconsistent with I. Right? But QQ plot for B is not approximately straight line. So, sorry, this one is.
Wait, sorry.
ไม่เกินกันเลยอ่ะnot normal
Not normal. I'm not.
Hey, did you bring vodka? Sorry? Vodka?
consistent
Kill me.
with time
Fair.
I know you're tired, but yesterday
No
I
more pop.
have to teach 3 hours in the morning, 9 to 12. 3 hours in the afternoon, 1 p.m. to 4 p.m. And then 3 hours at night. And I was tired. 9 hours. Next week I have to be like, see you in at night. Then Tuesday is always like that. But still means that I have more energy in your class than the class. That's a good thing or bad thing, I don't know. Most of the time when I get sick, I teach.
Yeah, I know. Yes. It's a good,
Okay,
it's a good one.
that's
Oh. Yeah.
the first one is not consistent, and the second one consistent.
Random story.
Because remember, they both are not normal, right? But on this one, you can assume normal, right? This one you cannot assume.
What percentage?
But
What percentage?
Percentage.
98? Still stuck?
right,
Right now? 98.
Still stuck.
Almost.
How? How to do it? Every time. Where is she? Where?
so today we review the whole stuff, right? On sample t-test, right? And then we learn new stuff and sample t-test, right? The crucial one is that you have to be able to tell whether they are paired or not paired, right? And we learn how to use the tool sample t-test, right? Next time we will learn when we have more than 2 samples, right? The sample maybe quick look in, if you have 15 minutes, let's take a quick look on this.
I'm excited to hear about it.
Another sheet that say ANOVA examples.
ANOVA. ANOVA.
Right? So this one, the setting saying that because there are no national regional standards, it's difficult for UC admin committee to compare graduates from different high schools. So basically, they want to compare students from different high schools. If the high school, if they think how they do good or bad in the college or not. University admin have to note that 80% average of high school with those standards may be equivalent to 70% average at another school. In effort to more equitable compare application pilots, study was initiated, right? It said that random samples of students who were randomly were made to the previous school year from 4 local high school. Now we have 4 samples from 4 local high school. All right, were drawn, and they have drawn randomly. All right, all students enter the business program with average between 70% and 80%. Their average grade in first year at university were computed. Also assume sample are drawn from normal. Alright? The thing is that now you have 4 samples. School A, school B, school C, C, and D. Alright? And then what they do, they compare the score on the first year that they have been done on university. Alright? To make it simple, just look at this output. Maybe take a look at this graph first. Output 7. Now we have 4 schools, A, B, C, D. This value here is a score, right? The score of the GPA from the first year, all right? So if the students are doing good, imply that that school have high standard, all right? If the score is bad, that school have low standard, all right? The question is that are there any different of standard from both schools? Right? It's more like comparing four schools. Are there any difference? Right? If they're not different, they have about the same standard. Alright, when you say different in terms of quantitative, you can compare three things: shape, center value, and spread. Right? But most of the time, the easiest is to be by comparing the center value to mean. Alright? Now maybe let's take a look at side by side box plot. Are there any trends that they are different? Possibly. Right? If they're different, right? Which one you think is the best? See? You're from that school, huh? Which one seems to be the best? A. Right? A is highest. Highest score. See? Maybe take a look at the median. It's highest. Which one seems to be the worst? C. It's hard to tell, but it's kind of, if you look at the median, it's C. But median is kind of like very spread all over. Alright, but this one is pretty kind of, they have some kind of trend that this one is the best. Alright, so that's a kind of sign that somehow different from four schools. So maybe these four schools are different. Alright, how about if you take a look at histogram? Do they look different? Do they look different? Is it a big obvious difference? Hard to say. And you see the shape there, about bell shape kind of, right? Location are somewhat different, but it's hard to tell because like the sample size is not so big. Alright, the spread they kind of different, but it's hard to tell also. And in this case, I think side by side buffer is a lot easier to use. Just too detailed to make a judgment. Right? But we can also compare by using point estimation and interval estimation. I'll put one, same old thing. Alright, start by first level by compare the means. Alright, in terms of center value, you compare four means. Are there difference? How many of them? I will start by comparing the maximum to minimum. When I say different, don't have to be all mutually different. Just only one pair would be enough to say that there are some difference. Okay? Alright? If you pick the top one, 70. Right? The minimum one would be different by about 8 points. Is that a lot? Is that a lot? Can I deduct your score by 8 points?
No.
You see, 8 points is a lot. Dang, 8 points is a lot. Alright? Okay, this is different by 8 points. That's what I mean by how big or how small in terms of that context. This is a lot. This is like 2 grades almost. Okay? Alright? So there has a big sign that there's a difference here. Right? How about in terms of spread? You compare S. Do you think that they're different? There's some sign on like this one and this one a little bit. There's some sign that there's some difference there. Right? But I think that some people might think that there's some kind of thing that holding back a little bit. You know, that's like I told you that if it's not different by 2 times, 3 times, maybe you might it's not a lot of big thing there. But you see, right? You can also compare by confidence intervals. We have confidence from A, B, C, D. Right? Are there any difference among 4 schools? What kind of thing you have to look at? Overlapping or not? If they're all overlapping, they are all about the same. Are there any pair of the interval that's not overlapping? Look closely. Look at your sheet also. Yeah? No. Huh?
No.
signal, right? Because they are overlapping, right? Yeah. You can pick 65 and 65 is all that, right? You see, 65 here, so we can put all people the same. So based on these four intervals, they are not different, right? But this one and this one, they almost not overlapping, but based on this one, they all are the same, right? So that same old trick can also apply. Later on, next time, we will learn how to use this case over. Alright? At the end, you see we have this output, we have this p-value, we have this f is called what test. Next time, we will learn this p-value, what is S0 and what is HA. At the end, it's going to be talking about means when you have many means to compare. Alright? I'll stop here for now. Next time, we see in the lab.
Okay.
Okay,